Welcome students. In today's session, I'm going to take you in Kolbe's electrolytic reaction. This reaction falls under decarboxylation of carboxylic salt. Decarboxylation means that to remove carbon dioxide from carboxylic acid. So from this reaction, we can produce hydrocarbon compounds. We can produce alkane, we can produce alkene, but also we can produce alkyne. But for today, we are going to prepare alkane by using Kolbe's electrolytic reaction. Then to produce alkane, we have to use 2 moles of carboxylic salt. For example, if we use CH3COO sodium, this is a salt of sodium acetate, so it is sodium acetate. So when this under electrolysis, we are going to produce acetate ion COO plus sodium ion. So we have to use 2 moles of sodium acetate. Then we are going to produce 2 moles of acetate anion. Then we have to produce 2 moles of sodium ion. Underwater, then this will produce also hydrogen ion plus hydroxyl ion. This is negative. But also now we are going to use 2 moles of water, producing 2 moles of hydrogen ion, but also producing 2 moles of hydroxyl. Then we know that we have to use electrolysis. Then we have to start at the anode. At the anode means this is a positive electrode. So having these ions, when we apply electricity, then these negatives will migrate to the anode. Okay, but acetate ion will be discharged in the preference of hydroxyl. Then at the anode it will be CH3, C double bond O, this negative. Then this one now is going to lose electron. It's going to lose electron, producing it loses electron. This we have 2 moles. Then it is going to produce acetate free radical, C double bond O, then oxygen plus electron. Remember, we have 2 moles, then 2 moles of electron will be lost. This is remain as a free. And remember, oxygen we have 2 bonding electrons and 2 non-bonding pair of electrons. Then this compound here is called acetate free radical. Okay, this compound is unstable, so it is going to undergo rearrangement. CH3, C double bond O, C free radical. Then here remember it is bonded to 2 electrons. Then this is going to come here. This electron, one of the electron will break coming this way, and also this now will break going this way. Then we are going to see the product as CH3 free radical plus carbon dioxide. Okay, remember we have used 2 more, then 2 moles of carbon dioxide. Then these are called methyl free radical. Then the 2 methyl free radical will combine together then to produce CH3, CH3. This is called ethane. Then at the cathode, then hydrogen ion and sodium ion will migrate to the cathode, but hydrogen being with the less electrode potential, it will be discharged in the preference of sodium. So now hydrogen ion will gain electrons. There are 2 moles of electrons, then to produce hydrogen gas. This is hydrogen gas. Okay, then these 2 electrons which has been lost there. Okay, then remember we have also sodium remaining in the solution, but also we have hydroxy. Then also 2 moles of sodium will combine with 2 moles of hydroxyl, then to produce sodium hydroxide, 2 moles. Then now we can write the general reaction by writing that if we take 2 moles of sodium acetate, okay, plus water, 2 moles of water, then we are going to produce alkane, which is CH3 plus carbon dioxide, 2 moles, plus hydrogen, then plus sodium hydroxide, 2 moles of sodium hydroxide. Now this will be our general reaction. Then thank you very much for listening. Continue following me. We are going to produce alkane in the other lessons. Thank you very much.